Let's briefly recap MVC controllers in the context of the request lifecycle. Controllers are the most important classes you'll work with in MVC, so we really want to understand how they're created and executed. At a conceptual level, controllers are of course responsible for orchestrating the relationships between views and models. At the low-level code, however, a controller is really nothing more than a class that implements the iController interface. iController is very simple. It just defines one very important method called execute. This is the method that really pushes the MVC execution pipeline forward. It's interesting to note that this method is actually fairly generic. You could build a controller that handles requests in any number of ways, as long as it implements this interface. Action methods and other layers of .NET MVC are a conventional and very powerful implementation that's provided by the framework. However, you could customize the process for generating a response quite extensively. You could theoretically have a controller that just writes out plain text as the response, or maybe another that has some custom way of working with XML. The built-in controllers and extension points of MVC can do all of this and much more, so most of the time you'll simply be building off of the abstract controller base class that's already provided by MVC. The low-level execute method of iController is already handled for you to provide more useful capabilities. So where does the controller's execute method get called in the request lifecycle? If you remember back to our first module, we looked at this chart of the overall request lifecycle. The controller initialization and execution actually all happens inside of the process request method of the MVC handler, which was selected during the previous routing stage. Let's isolate this controller initialization section and look at it in more detail. So the MVC handler's process request method is ultimately responsible for generating a response to an incoming request. To do this, it must create and execute a controller. The MVC handler does not complete all of this work on its own, though. Instead, it leverages the help of a few other important classes. First, it calls a child method named processRequestInit, which asks a component called the controller factory to provide a controller for the current request. The controller factory selects an appropriate controller class from the current application using the supplied route data. Remember, the controller name is populated when the current URL is mapped to a route that we defined in our application. Next, the factory uses a component called the controller activator to actually create an instance of that class. The selection and instantiation of a controller is broken into these two different steps to allow for greater extensibility and isolation of responsibility. The controller activator uses a dependency resolver when instantiating the requested class. This is a powerful feature and it allows patterns like dependency injection to be implemented. And if a dependency resolver cannot create an instance of that controller, the activator will try to do it manually. After the MVC handler has acquired a controller from these steps, it calls the execute method on that controller. It's from within this method that all of the powerful tools like action methods are exposed and begin processing. Before we get too far into discussing the controller's execution though, let's look at a few of these components in detail, starting with the controller factory.